In this next little part, we're going to talk about increasing and decreasing functions. Now, in layman's terms, a function is going to be said to be increasing if, as you trace the graph from left to right, it goes in the upward direction, meaning it has a positive slope. And we're always going to look at it reading the graphs from left to right, just like you read a book. So that's what we're always looking for, is that upward motion if we're talking about increasing. Next, we're also going to talk about decreasing. A function is decreasing if from left to right it's actually going to be going downward, meaning it's got a negative slope. And lastly, a function is going to be said to be constant, meaning it's not increasing and it's not decreasing. It's constant if its slope is actually 0. Meaning it's not going up, it's not going down left or right, it's just a flat horizontal line. So if you have a horizontal line, its slope is 0, which means your graph is constant. It's not changing. It's not going up and it's not going down. Now, what we want to do is talk about how to find out when a function is increasing, when a function is decreasing, that sort of thing. The key to being able to find out when a function is increasing or decreasing really does hinge on something super small, which is that you're always looking at your graph from, whether you're increasing, decreasing, it's always from left to right, which means that when you're reading when a function is increasing, decreasing, or constant, and you're reading it left to right, means you should be using x values to describe when you're increasing or decreasing, which means you should be looking at domain values. So really, the only time you should ever be using y values is if you see the word range. Whenever you see increasing, decreasing, constant, or domain, you should be using x values. If you do, however, see range, that's the one time you're going to be talking about using the y values. And when you're doing your y values, that's when you're doing your up and down. And when you are doing your x values, you're doing your left and right. Now, also for increasing, decreasing, and constant, we're always going to use for increasing, decreasing, and constant, we're always going to use open intervals. And sometimes in the homework, they'll even say open interval. What does it mean by open intervals? It means you're never going to be using brackets. It means you always use parentheses. That's what an open interval means. And by using an open interval, using parentheses, what doesn't happen is you don't end up with an overlap. If you use brackets, a lot of times what you can end up with is a spot on your graph where you're both increasing and decreasing. And that's not possible. It's kind of like saying that you can move your car forwards and in reverse at the same time. And you really can't do that. So we're always going to use parentheses when we're talking about increasing, decreasing, and constant, because you can't do anything at the same time. And if you start using brackets, you'll end up having some overlap, or there's some values where you would be doing both at the same time, and it doesn't make sense. So what we would like to do instead is just leave out those values and kind of say that those are changes in direction. And I'll show you what I mean. So let's take a look at a couple of examples. Let's start out with this first example problem that looks like a parabola pointing downward. And we'll talk about when is this function increasing, when is it decreasing, and when is it constant, and what's its domain and range. So let's talk about one thing at a time. Let's talk about increasing and decreasing? Well, as we trace our graph from left to right, and I'll just only trace this first half of the graph from left to right, notice I am going up on the first part of the graph. So I have a positive slope. That's the part of my graph where I am increasing. Well, how do I write that out in interval notation? Because they said that they want intervals. Well, it's increasing from, on the left side, negative infinity, and it stops here at this point here at 0. We know that negative infinity, we always use a parentheses. However, with increasing, decreasing, and constant, we said we're going to use open intervals. So we're always going to use parentheses. Now the question becomes, when am I decreasing? Well, when am I decreasing? Let's take a look. Well, continuing to trace my graph from left to right, notice the right side of my graph is continually going down as we work our way towards positive infinity. So that means that part of my graph is decreasing. So that's going to start where we left off at 0 and continue all the way to the right to positive infinity, which always has a parentheses. Again, just like before with increasing, decreasing, and constant, we're always going to use a parentheses. Now notice, had we used a bracket instead at 0, what we would have had is that you'd be increasing at 0 and decreasing at 0. That isn't possible. It doesn't make sense. You can't do two opposites at the same time. So that's really why we use our parentheses. So I'm increasing or going up all the way up to 0, and I'm decreasing anytime after 0. But what's happening at 0 is I'm changing direction. I'm changing from going increasing to decreasing. That's why we don't include 0 in either of the two ideas. We leave the parentheses saying that 0 is kind of its own thing. We're changing direction here at 0. Okay. And the last thing is, when are we constant? Well, on the left side, we're increasing. On the right side, we're decreasing. I don't see anywhere where it looks like a flat horizontal line, so we're going to just say never. Now, the question is, what is my function's domain? Meaning, reading this graph from left to right, where do I have a graph? Well, notice from left to right, I have a graph everywhere. So my domain is going to be negative infinity to positive infinity. And let's see about my range. My range has me reading my graph from bottom to top, working my way from negative infinity towards positive infinity. And what we notice is my graph does start at negative infinity, but stops in the middle at 0. So we've got negative infinity to 0, and then there is no graph after that, so we're going to stop at 0. Now, remember, domain and range, we can use brackets. We don't have to always use parentheses. That's only with increasing, decreasing, and constant. So, because I have a graph here at 0, 0, I do want to include 0 in my range, so I'm going to put a bracket there. Let's try another problem. Let's take a look at this next one. On this next one, let's trace the graph from left to right. So we'll start on the left side and work our way down. Notice this first little piece that we've got traced is that we're going downward. So that's where we're going to be decreasing. Notice it starts all the way on the left side at negative infinity and stops at our point. Well, our point here is at negative 1, 3. So do I use the negative 1 or do I use the 3? Well, remember, I'm reading my graph from left to right most times. So I'm going to be using left to right means x value. So I'm going to use the negative 1. So it's going to be decreasing all the way up to negative 1. Remember, no matter what, infinities use parentheses, and because we're doing increasing, decreasing, and constant, we're going to always use open intervals, which means we're always going to use parentheses. Okay, keep on tracing my graph from left to right. Let's see what comes next. From left to right is this little middle piece. What do we notice about the middle piece? It's not going up or left from up or down from left to right, so that's our constant piece. So let's take a look at our constant piece here. When are we constant? Well, from left to right, that means we're using our x's again. We've got -1, 2, 4. Again, we have to use open intervals, so we have to use parentheses. Our last piece, when am I increasing, is on that last little piece on the right. Notice that I'm going upwards from left to right. So that means that's when I'm going to be increasing, which is again starting at that point, which has an x value of 4, and continues on forever to the right to infinity. And again, we're going to use open intervals, so a parentheses. Now let's talk about our domain and our range. Our domain means looking at our graph and tracing it from left to right. Well, from left to right, notice our graph goes both in the left and the right forever without stopping or ever having to pick up your pencil. So our domain is going to be -infinity to infinity. There's a graph everywhere from left to right. However, that is not the case with the range. Let's take a look at the range. With the range, we work our way from the bottom down at -infinity. Up towards the top at +infinity. Now notice there's no graph on the bottom until we get to this line, which starts at what value? Well, this is where you use your y values, because this is the only time we're talking about from down up. We're talking about the range, the y values, which means we're going to start at 3. Comma. Then notice our graph does go up forever, so that'll be comma to infinity for our range. And again, remember, infinity always uses a parentheses. Now the question is, what's going on at 3? Well, there is a graph at 3, so we need to include it. So I'm going to use a bracket. Remember, the only time we really are forced to use open intervals is with the increasing, decreasing, and constant. Let's try another one. Let's take a look at the next problem, problem number 3. Let's trace our graph starting from left to right as one big piece. And notice the one big piece is always going down from left to right, which means our graph is always decreasing. It's always going down from left to right. So from on the left side, -infinity, to the right side, +infinity, we're going down forever. So the entire graph from -infinity to +infinity is decreasing. And we'll put parentheses around that because that's kind of our rule. So when is it increasing or going up? Never. It's always going down. And when is it constant? Never. It's always going down. What's our domain? Our domain has us looking at our graph from left to right and saying, where do I have a graph? Well, I have a graph everywhere to the left and everywhere to the right. So my domain is going to be -infinity to +infinity. Let's take a look at my range, my y values. Well, starting down at the bottom at -infinity and working my way up towards +infinity, what we notice is that our graph goes down forever and up forever. So that means our range is also in -infinity to +infinity. And this graph you should have seen before. It looks like the cube root graph because it kind of looks like the cube graph on its side. Actually, it's also been reflected over the x-axis. It's like it's an upside down cube root graph. So this is kind of a little bit different.